You're watching America's News Channel, MSNBC.
The following program is a special presentation of America's News Channel, MSNBC.
Seeing deep inside the human brain, unlocking the secrets of the heart, discovering the blueprint to life itself. Medical miracles, unprecedented challenges. We are on the threshold of a revolution.
Summit for a Cure. From Cleveland, Ohio, and the Cleveland Clinic, here is Brian Williams.
Thank you. Good evening and welcome to the Cleveland Playhouse, which is adjacent to the Cleveland Clinic, and that is indeed what brings us to the fair city of Cleveland, Ohio tonight. The Cleveland Clinic, widely considered to be the leader in this nation in heart health and heart surgery, and that is just one of the places we will go tonight in what we hope will be an extraordinary and educational 2-hour journey through the human body and through science and hope to look at what's out there already, and the future. We have assembled some of the best and the brightest, the best minds in science and medicine to help us for what we know will be a lively conversation and discussion along the way as we begin our Summit for a Cure. We will explore a world of stunning progress in medical technology and human knowledge, breakthroughs in genetics, targeted treatments, precision instruments, and wonder drugs, making the miraculous seem commonplace. A brave new world in which cures for some of our deadliest diseases may be at hand, including heart disease and some forms of cancer. Later, we'll hear from Christopher Reeve, paralyzed for 7 years now, a leading advocate in spinal cord research and the controversial use of human stem cells. Actress Fran Drescher with a fascinating story to tell about her own fight with cancer. And we'll look in on an actual heart operation in progress, a state-of-the-art valve repair conducted as we speak. You're going to hear us use the expression "the best" many times tonight because, as I mentioned at the top of the broadcast, that is precisely what we have assembled here this evening. And we're going to have a lightning round of sorts, doctor by doctor, expert by expert, to set the scene. How much hope should we have? Are we, as one expert put it, really in the middle of a revolution in medicine? So we do have the best assembled for us tonight, headed by Dr. Larry Norton, who is the head of oncology at Memorial Sloan Kettering. And I urge the audience at home and here in the theater not to judge the physician by the broken kneecap he has brought in front of him tonight, the result of an unrelated accident to medicine. Doctor, in your specialty, very briefly, are we looking at a cure for cancer?
It's extraordinary what's happening now. First of all, we cure a lot of cancer already, and I think that's because of a lot of hard work. But now we have the blueprint, the DNA, that tells us what cancer is all about. And we're going to see an explosion of new therapies, new approaches based on that knowledge. It's an extraordinary time to be involved in cancer medicine.
More on that great hope in just a moment. Dr. Ron Krall is with us from AstraZeneca. You can speak to the miracle drugs out there. Is that an improper use of the term?
Not at all. Millions of Americans today take medicines each and every day of their lives in order to play an important role in their families and in their communities. For them, the medicines they have today are miracles.
Dr. Eric Topol is on home turf here, a cardiologist at the Cleveland Clinic. You didn't have to walk far, Doctor. When we look at heart disease, is that something like cancer, like various forms of cancer, that we can really cure?
Well, there's many forms of heart disease, Brian, but certainly the most common form, the arterial disease, that we now understand inflammation, unraveling the genes. We're at the midst of a very exciting time to be able to turn around heart disease as we know it today.
Dr. Gary Small is with us as well, a neuroscientist, head of the Office on Aging out at UCLA Med. Gary, we're going to be talking about things like Alzheimer's, Parkinson's tonight. Is the glass half full or half empty?
Brian, I'm convinced in the next 5 to 10 years we're going to see major breakthroughs in early detection and prevention of Alzheimer's. But what most people don't realize is that today there's a lot we can do to keep our brains healthy and young and stave off future memory loss.
Huntington Willard, a geneticist at here in Cleveland at the university hospitals. When we're talking about superhumans in this day and age, how real is that?
I think we have to look at the brighter side of the Human Genome Project and the information that's coded within our genes. I think, as you've already heard, it's going to give us the capacity to diagnose and eventually treat a whole host of diseases. Whether that lets us to be superhumans or not, we'll be healthier humans.
Dr. Eve Slater is a deputy at the Department of Health and Human Services. And a note to our audience watching at home tonight, she has two big bosses. One is named Secretary Tommy Thompson. The other is President George W. Bush. You might have heard of the latter. So, Doctor, be candid with us here tonight, will you please? Does the government ever stand in the way? Is the government, as they say, here to help or here to watch over things?
Well, Brian, it's a pleasure to be here, and just to tell you, as you know, the president has completed his pledge to double our nation's research budget. We now have to translate that research into patient care, and then where our job really comes in is to teach people how to lead healthier lives through disease prevention, and that's what we're trying to do.
Dr. Glenn McGee is from Penn, for the East Coasters with us, a bioethicist who has a lot to say on the power of this government to potentially change life forms, change life in this country.
It's really an amazing time. I mean, it makes the laptop, atomic energy, so many of the miracles of the last 200 years look quaint by comparison. But just like those miracles, so many Americans can't afford or don't understand the new technology. How will we make sure that access is there, that access is safe, that we've got good regulations, and that ultimately we're educating Americans to make good choices? It's an ethical, really an ethical knot. We've got to figure out how to untie it.
Dr. Mehmet Oz is known to many members of our audience. His book, Healing from the Heart. Doctor, are we making a very big mistake here tonight by not using aromatherapy, reflexology, stretching as we should be here in the studio? Are we about to concentrate too much, in your view, on traditional medicine? What should the mix be?
I think there's a healthy mix that we can achieve because integrative therapies broaden the vista, the opportunities that we can achieve. So using the traditional forms of medicine that we're comfortable with, manifested by the members of this panel, and combining with other remedies that really are global in scope, therapies that are used by 1 billion people in China and other parts of the world, is a smart move for medicine. Remember, wellness is not just a matter of spending money smartly, it's a matter of being aware.
Now, here at the Cleveland Clinic, we should say there is a whole lot of surgery going on, heart surgery going on virtually around the clock. Tonight is no exception, and we're going to light up the big screen behind us here. We are happy to be joined by Dr. Toby Cosgrove and a bunch of his friends. He is chairman of the Department of Thoracic and Cardiovascular Surgery right next door at the Cleveland Clinic. And allow me to embarrass him for just a moment. He is the holder of, 18 patents for devices he has perfected for the human heart. And perhaps we can salute him the most tonight for being the winner of a Bronze Star in Vietnam. There are a whole bunch of U.S. servicemen who are alive today because he stabilized them and evac'd them in a part of his life that must seem a long time ago. So can we hear it for Dr. Cosgrove before we go to him? Now, Dr. Cosgrove, you will forgive me, the man we cannot meet, because that would be his chest wall that we're looking at, is Jerry Gold, a 60-year-old from Thousand Oaks, California. He's a math professor, married with 3 children. We send him our very best. He is otherwise in perfect health, I understand, so perhaps you can tell us why there's a hole in his chest wall, Doctor.
Yes, Brian, it's nice to have you here. This is a gentleman who has got a leak in his mitral valve. And his mitral valve is causing his heart to enlarge, and this is the first sign that we think that we ought to do something to prevent him from eventually headed towards heart failure. So we're going to repair his mitral valve today, and we're doing it through a small incision about 2.5 inches long, which should reduce the morbidity for his operation.
We're going to try, knowing that in some time zones this is the dinner hour in the United States, to keep this rather sanitary, and our camera will be backing in and zooming up. But for the faint of heart, It might be a time to sample the audio portion of the broadcast only. Doctor, you're being modest because in the old days, this would have involved cranking open the chest wall. This is something you have perfected, a minimally invasive surgery. You're also going to do a repair and not a replacement, something they shun in the automotive repair business. Why have you come to love this technique?
Well, first of all, the incision is being done through about a 2.5 incision. You can see it's about as long as my index finger. And we think that that reduces the problems that are associated with getting over heart surgery. Second thing we want to do is we want to repair his valve. And if you look in here, you can see that one of the problems with his valve is that he's broken one of these little cords that support his valve that I have in my forceps here. And as a result of that, the valve leaks. It's very much like if you cut a couple of of the cords on a parachute, the air would leak out. Well, the blood leaks through here. So we're going to repair this, and that will avoid having to use a mechanical valve or some sort of an artificial valve in his heart.
It's extraordinary. Doctor, thank you. Continue your work. By all means, please continue your work. We'll check in with you and the progress of your operation later. You'll note what's different about that human heart. It is not beating, and we'll use that to hint about our future segment when we come back here tonight. We'll look at advances with the human heart, as complex an organ as it is, as delicate a thing as it can be, when we continue from the Cleveland Clinic here tonight. This is a heart, not necessarily a human heart. In this nation, it is quite possible that in the years to come, you will be able to meet someone on the street without a heartbeat. That is not to say the heartless among us. We all have one or two of those at work. This is made of titanium. It would simply hum like a small, low-amp motor. This is about $7 million worth of science in the palm of my right hand. It's a prototype. It would work entirely fueled inside the body, would work on its own. It's not quite ready yet, but there's a lot of science that is, and we're going to talk more about the human heart. If I can ask Mike, the stagehand, I've always wanted to say this, have a heart. It's an expensive one. Dr. Topol from here at the Cleveland Clinic. You have some very, very interesting views on the subject of the human heart. How much stock should we put in a $7 million titanium model, and how much stock should we put in drugs and or health?
Well, it's an interesting question that you bring up, of course, Brian, and that is that in the recent years, there's been several breakthroughs in devices for the heart, including not just the artificial heart, but also the defibrillators, the biventricular pacing both ventricles, and also the coated stents to prevent re-narrowing after the stenting procedure. Altogether, this could accumulate to about $100 billion per year of new expenditures through rigorous research and through great technology advance. So we've made tremendous progress, but of course, the dilemma is how to apply these devices.
I know that you have a special body of opinion reserved for those Americans who've refused to heed the warnings about fitness and about diet. And to use common English, here you are banging your head against the wall, trying to perfect devices and procedures and science, and yet, where does our nation stand on obesity and exercise?
It's a big problem in that we are making so much headway in understanding the disease and taking control of the arterial inflammation. But on the other hand, we have the most obesity ever in the United States, the most diabetes, the least exercise, and essentially lifestyle has deteriorated to such an extent. This is a big problem. There's very little being done to promote it. Fortunately, of course, we saw yesterday with President Bush promoting the run and the First Lady with the walk. Those are good things, but we don't do enough to promote a healthy lifestyle in this country to prevent cardiovascular disease and other important diseases like cancer.
Dr. Slater, as we mentioned earlier, you happen to be the representative of the federal government here tonight. That great line from The Wizard of Oz comes to mind. He says, "Now I know I have a heart because I can feel it breaking." These doctors would much rather have everyone walking around with beating human hearts instead of pieces of hard hardware. What can you tell us about getting the American public where they should be? That's a very interesting view Dr. Topol has.
Well, there are very, very simple things that everyone can do. Exercise, as Eric says, eating properly, taking good care, just learning a little bit about your health and following very, very simple rules. That's where the hope lies, really, Brian. The hope is that we can actually prevent many diseases from becoming the more serious kind of diseases that require interventions and a lot of morbidity and mortality that go with them.
Dr. Oz, this past week in the news, we've seen a major airline in trouble in a PR sense because they want to charge for 2 seats for those for whom one is not enough. Go to any major public venue, come to our home, 30 Rock in New York, go to Disney World, and you'll see the Americans who are overweight and know it. In this day and age, what would you grab a hold of them and have them do?
Well, at the outset, I should emphasize that part of the epidemic is caused by the kids in our society who are gaining weight at such a precocious rate. And that's a problem that is mortgaging our nation's future. So I would focus initially on schools. The reason we advertise to children is they translate knowledge to action very quickly. At our age, we don't do that as fast, and as we get older, we definitely don't do it any quicker. So if we can re-educate our kids about the awareness of how precious their body really is, it'll probably be the earliest way that our nation's leaders, like Eve, can play a role in re-educating us. In addition, those kids will help educate older Americans about how precious what they really have is. It's part of our life journey.
We're going to talk a little bit later on about your teachings and your writings. How cynical a public are you up against, though? We mentioned at the top of the broadcast reflexology, yoga, aromatherapy. You know, a loved one of mine takes an echinacea or 2 every time, here's a hint, she feels a cold coming on, and I say, you know, if they worked, wouldn't major hospitals and universities hand them out? Knowing that she's here tonight, am I correct?
Well, let's be provocative about this. First of all, you have to spend money to research some of these therapies. The wonderful advances that Eric Topol and his colleagues have made, and I'm a heart surgeon, so I share the really bright future that I think we have in this field. These advances were made because we spent hundreds of millions of dollars advancing these therapies. Many of the alternative options that, for example, your wife might like to quote.
I didn't say it was my... Oh.
From prior conversations, I can admit.
All right.
Would be established as being either beneficial or a complete waste of time if you could invest the time to learn about it. But in fact, we haven't been able to take that dollar investment because many of these therapies aren't patentable. There's no return on the investment. Ask the average member of the audience, of our panel, if you own stock in a company and that company wanted to spend $25 million to get through the federal government a therapy for which there was no profit, would they invest that money? Of course they wouldn't. And that's one of our major economic challenges.
Dr. Topol, I didn't mean to put words in your mouth either. I assume you would much rather use a beating human heart than a $7 million titanium replacement part.
That's right. The whole focus is on prevention. Most of the people who would be candidates for an artificial heart would be one with end-stage heart disease, where they had such extensive disease, they succumb to heart attacks. And this is, of course, what we want to prevent. This is a disease that's eminently preventable over the years ahead with the information and the insight that we have today.
Dr. Cosgrove, I understand, next door at the Cleveland Clinic has reached a crucial point in this operation. Doctor, we're back with you. Tell us what exactly is going on now.
Well, things are going along very nicely, Brian. We're just at the point now where we've put the sutures in. We've removed the portion of the valve that is not working normally. And we're doing the final step, which is to sew a ring around the valve so that it doesn't stretch out in the future. So as you can see, what I'm holding in my hand here is got a little piece of cloth attached to it right here, and that will be left in the heart, and the rest is the holder and gives it structure. And all those little strings that you see are attached to the annulus. So I'm going to slide it down into position into the heart now, and then we'll remove the handle, and I'll start tying these stitches as we go along.
All righty. Doctor, in another way of describing what we're seeing, the green plastic superstructure is merely that. It's been described to me that you're filling a tent with a balloon, and the white part at the bottom part of the screen, the U-shaped part, is the spine of the tent. You will remove the green plastic part, the spine remains in place, so you get to keep the original heart valve. It is being forced artificially to stay open. Does that about get it?
Yeah, I think that one of the nice things, what we're trying to do is all these valves have the ring that the valve is in is stretched out. And what we're trying to do is return it to a normal size. And we know that the heart has a shape and needs to move afterwards, so we can't put in something rigid. So what we did is we took the idea from essentially an embroidery hoop. And the embroidery hoop holds the piece of cloth taut while we pull the threads through. In this case, it is the green plastic that is holding this in the right length and size while we tie the knots down, and then we're going to take it out when we're finished.
Doctor mentioned an embroidery hoop. One of his claims to fame in medicine is using household items, or at least getting inspiration from them. Doctor, what was the idea you had from a bicycle brake?
Well, there's a clamp here that you can just see in the left-hand side of the field. What we wanted to do is all the clamps are sort of rigid, and they have to have multiple different angles. So we figured that if maybe we took and made the handle out of a flexible material, much like a handbrakes on a bicycle, we could bend it out of the way and then have one clamp that would sort of fit all purposes.
Doctor, let me pick an arbitrary year, 1970. What kind of surgery would you be performing for a similar ailment, or would the patient have made it that far?
Well, first of all, Brian, we wouldn't have operated on this patient anywhere near as early as we are now. Because cardiac surgery was so crude and the risk was so high that a patient who was relatively asymptomatic would not be operated on in a preventive mode. So this patient wouldn't have gotten operated on. He wouldn't have come in until he sort of came to us on his hands and knees in terrible condition. And then the risk was very high and they didn't get better afterwards. And what we would do would put in a metal valve that was associated with a lot of complications, including blood clots forming on the valve, etc. This has the advantage of taking a valve and returning it to normal function, and we can do it at a very, very low risk. The risk is a fraction of 1%, and so that this gentleman should be returned to a completely normal life with a normal functioning valve, with a 4 or 5 day stay in the hospital.
I don't know what's more extraordinary, the operation or the fact that we are watching it from virtually inside the human heart. As I hold in my hand the device the doctor is sewing in, it's the green plastic part he will pull away, and the white spine will remain and open up the valve. We are going to take a break. We realize there are so many different categories of medicine we must discuss tonight, and oh, the places we will go. When we come back from a break this evening, the topic of cancer, top of mind to so many people watching along with us tonight. We'll talk about the advances and the search for a cure there as well.
Summit for a Cure. From Cleveland, Ohio, here again is Brian Williams.
Good evening once again, and welcome back on what is a warm early summer evening here in Cleveland, Ohio. We're coming to you from the Cleveland Clinic, and in this 2-hour discussion, we have so many topics, so many advances to talk about. We would like to take on the enormous topic of cancer, where there have been advances compared to 5, 10, 15 years ago in areas of treatment, radiation, chemotherapy, specifically the new thing, as they say, targeted therapies. NBC News caught up with one specific case a year ago, a groundbreaking clinical trial. Trudy Webb began her battle with cancer 10 years ago. Chemotherapy, surgery, and more radical treatments were becoming routine. Fearing yet another tumor, she decided to have it checked out.
I had gone to the doctor just for an annual checkup and said, you might want to check, why is one side of my stomach getting larger than the other? And he felt of it and said, my goodness, it feels like you have a very large mass in there. And they did testing and found out that I did have a very large abdominal tumor at that time.
The diagnosis, a gastrointestinal stromal tumor, a rare form of cancer.
I had steady back pain, and within a day, I could feel, and I could also feel my tumor growing, almost multiplying, cells popping out. Almost every day I could feel it growing.
To make matters worse, no course of treatment available was able to help her. And that's where Dr. Charles Blanky came in. He suggested she join a clinical trial, the treatment of pill called STI 571, commonly known as Gleevec. It's a form of what's called targeted therapy. Dr. Blanky explains how it works.
This whole plan of research where you find a specific and hopefully solitary reason that the cancer cell is behaving badly, you turn that off. And if you can do so or target your therapy to the reason the cancer cell is cancerous, you would expect the treatment to work.
I thought that I would not see another spring, that I would not be able to go fishing or play with our dogs. So many things I would never do again. And I am. I'm doing those things again. And if that can happen for me with what we thought was a very rare form of cancer, there's hope there. There should be hope for everyone.
And we are back, and here with us in the studio, Dr. Charles Blanky and Trudy Webb. Welcome to you and good evening.
Thank you.
How are you feeling?
I'm feeling very well.
There was a time when you didn't dream you'd feel such an unusually warm early summer night in Cleveland, Ohio, I assume.
Right.
Tell us about looking in the rearview mirror now and how happy we are to be able to say that. Your view of clinical trials when people knowing your story approach you and ask you.
Clinical trials are one person's hope for cancer cures or cancer relief. It was the only thing that I had to look forward to once I hit a point where I was inoperable. I think that there's a lot to be held for anyone's hope for a cure or for something to look forward to when you have cancer. Clinical trials are there. It's the future. It's something to hang on to when there's nothing else left.
The part of your story that struck so many people, I'm guessing, is when you sensed you could feel the cells multiplying, and it must have been among your darkest days.
It was right towards the end when I was scheduled for a reduction, hopefully a tumor reduction. I could feel that growing every day, and it was a very frightening sensation to know that maybe it was planned for my life to come to an end, and I could just feel that going, and there was no other hope.
Well, you're the physician here. Tell us about Gleevec and your opinion of this as a marker, as an indicator, as a reason for hope for other patients who may be watching today.
That's exactly what it is. Gleevec is a drug that helps a lot of people with relatively rare diseases right now. But more important, it's a blueprint for the future and how we're going to do research in cancer.
For every Gleevec, how many are there that won't work? For every Trudy, how many patients are there who won't be so fortunate?
Well, what we want to do is decrease that percentage and increase the percentage that are like Trudy. And so we're taking findings from the rat, the mouse, the test tube, moving them into early clinical trials and then hopefully into successful later trials with patients like her.
How do you deal with patients in the very darkest days?
Well, Trudy's a perfect example. I was asked to see her by one of my surgical colleagues who had nothing left to offer her with resection. And we knew that she had already failed innumerable standard chemotherapies, and her only hope was this clinical trial. Our goal was actually to keep her alive long enough for it to get through all the regulatory paperwork and get her the actual drug.
What is the prognosis for this very vibrant and life-loving woman who is sitting next to us here tonight?
It's wonderful. I met her 2 years ago, literally on death's door. She's been in remission since about 3 months after I met her. I've been seeing her every 3 to 6 months, and every time I see her, her disease shrinks by about another 5% on the CAT scans.
I want to bring in our experts at this point, and as we mentioned, from Sloan Kettering in New York, Dr. Norton. This opens up a huge area, obviously, sure. Doctor. And perhaps the same question earlier, for every patient like Trudy, for every medication like Gleevec, perhaps you can finish the sentence.
Well, the model is there. We're seeing the beginning of the end of cancer here. Cancers, there are probably 100 diseases that we classify as cancer, but they all have a common characteristic of the cells dividing too much and not dying under appropriate conditions. And that's all caused by defects in their DNA, defects in their genes. finding what those defects are and attacking them with molecules that attack the defects specific to the cancer, that's really what it's all about.
When you say, and a man of your resume and background, the beginning of the end of cancer,
Yes.
Millions of people at home want to know exactly what you mean. The patients with myeloma and melanomas and
Right.
all the other forms. What's in it for them?
We're finding out the molecular defects, the actual defects in the chemistry of the cell that's leading to all those diseases. And once we define those defects, we can also design molecules with the pharmaceutical industry, with the help of the government, with the help of academia, find molecules to attack those defects. We've been shooting in the dark up till now. We've been doing remarkably well considering how little we've known about cancer. But now that we're actually defining what is the cause of cancer down at the fundamental level of DNA, the whole world is going to change.
I owe it to those watching. Name a few. Lung cancer, breast cancer. How close are we in all these categories?
Colon cancer, prostate cancer, bladder cancer. All of these cancers are now being studied in terms of what is it about the cancer that makes it a cancer. What is this precise defect? And once those things are defined, then we'll be able to design molecules. Now, it may be more than one molecule. GIST tumors, chronic myelogenous leukemia, these may be examples where there's one defect that actually makes the cancer cancer. Many cancers, it may be 2, 3, 7 defects. So they're going to have to be defined in the individual case. But we're developing the tools to be able to do that. And once we have those tools, and they're developing rapidly every day there's a new discovery in this area. Once we develop those tools, then we can design molecules to attack those problems.
Dr. Kroll, as you might have guessed, you're on. You're here representing the pharmaceutical companies, however fair or unfair that is for one man. So we have the defects. We have the molecules. God knows, we know the illnesses and those suffering, and we've all suffered losses from them. Where do you begin? Who goes first? Who's next in line after that?
Well, this is a fascinating time, as Dr. Norton indicated, because we do understand now some of the mechanisms that are absolutely essential to the cancer cell. In our company, we have 5 different compounds that target different mechanisms that contribute to the dividing of that cell. And one of those is actually quite effective in some patients with lung cancer. We've been very gratified to see responses in those patients, and some patients living now for more than 2 years taking this compound. So these are the kinds of things that we're beginning to do. We're beginning to try to combine these different targeted agents to see if we can get an even better response in patients. We're moving out into different cancer types. This is an era that holds great promise for living with cancer.
Dr. Willard, every comment here tonight begs 20 questions. We'll try to make you an ethicist and someone who deals in the medicine side of this for all those with the lesser cancers, the diseases that don't get the attention. For all those in whom we might find a marker at age 5, what do we do?
Well, I think you have to start from the premise that not everyone starts with the same susceptibility or the same likelihood that they're going to develop cancer. Either because of different forms of genes that they themselves have inherited, or because of different genetic defects that creep up in various parts of our body as we grow and as we age. I think there are enough rules that are in common amongst different cancers that even the research that targets the most common of the cancers is teaching us lessons that are applicable to the rarest of cancers. And there's an old lesson in medicine, which is that when you have a disease or your family has a disease, you don't care how common it is or how rare it is. It's your disease. And so we have to find a way to take the lessons from the most common ones that get studied the most and apply those both in terms of genetics and in terms of the use of the human genome information to find the right medicines and the right approaches that will help those families and those individuals.
All right, we'll hold right there. We're going to fit another break in. When we come back, we'll have a discussion with a woman who is alive today. Is she ever alive today? Comedian and author Fran Drescher. She's alive today because of so many of the advances in science and medicine and the treatment of what was once terminal cancer. Stay with us. Ohio, at the Cleveland Playhouse. We are adjacent to the Cleveland Clinic. We have heart surgery going on right now, a valve replacement. We will check in on that later. We have, of course, nothing short of the world of medicine to talk about here tonight during one 2-hour broadcast. We brought up the subject of cancer, and I don't think it's an overstatement to say that we are joined by a woman from our Los Angeles bureau tonight who would not be alive were it not for some advances in medicine and science that have come streaming by us all, continue to. Fran Drescher is with us. You know her from The Nanny on television, and let's hope you bought and read her book, Cancer Schmancer, which pretty much sums up her feelings toward the disease. Fran, good evening and welcome.
Thank you. Thanks so much, Brian. I'm so happy to be here. It's such an important night.
Well, thank you. Thank you for participating. Your story begins with missed diagnoses, I understand, from several different physicians.
Yes, it took me 2 years and 8 doctors to get diagnosed with uterine cancer. And I was so frustrated by the time I was ultimately diagnosed that I decided that I needed to write this book to sound the alarm, because once you wake up and smell the coffee, it's really hard to go back to sleep. And I think that there are just so many early warning symptoms for cancer that can easily be misdiagnosed for much more benign illnesses, that it's very important that the American public know what those early warning symptoms are and know what tests are available. Because as in my case, it was confused for a perimenopausal condition. I went on 4 different hormone replacement therapies over 2 years. Nothing worked. My symptoms were progressively getting worse. And had I known then what I know now, I would have said with doctor number 1, please give me a DNC to check, the condition of my uterus. But everybody thought that I was too young to have uterine cancer. And unfortunately, I think that the profiles for many cancers are changing. And you're probably not too young for almost anything anymore.
Sadly, you're probably right. Fran, how bad did it get at its worst, and how dark was your life?
Okay, well, you broke up a little bit, but I heard you say how bad. So I'm going to assume that, you wanted to know how advanced.
How bad did it get? That's right.
My cancer was, maybe.
Yeah, that's right.
I was very lucky because uterine cancer is a very slow-growing, non-invasive cancer. So even after 2 years, I was still in stage 1, which means that there was no spread beyond the walnut-sized malignant tumor that was resting in my uterus. Now, mind you, I had had countless tests, and nothing seemed to show up this tumor. Ultrasounds, blood tests, pelvic exams. So these things really aren't 100%. And it's just very important that we speak about gynecologic cancers and what women can do to stay on top of themselves, because certain tests just aren't on the menu at a lot of doctors' offices. And also, I think that a lot of doctors are under pressure from insurance companies to not go for the more invasive, more expensive tests initially and see if the symptoms can be solved with easier, less expensive routes. And I think that that is, when I just took my book tour, people all over the country were saying over and over again to me that they went through the same thing. It took them years to get diagnosed, and they don't understand why certain tests weren't offered to them. So although back in the old days, in the 20th century, when we would go in and list our symptoms and hope that the doctors would give us all the available tests, I think now we have to become greater partners with our doctors and go in with not only a list of symptoms, but many questions, pencil and paper, and write everything down, ask them to spell things. You know, it's really your body. I don't give anyone power of attorney over my money, so why should I do it over my body? And when the doctor calls and tells you you have cancer at the end of the day, he goes home and has dinner with eats dinner with his family, and you go home and eat your heart out with yours. So it's very, very important that we don't keep our head in the sand, but really take control of the situation and almost be very directive. And if you feel like you're not getting the right attention or you're not getting all the tests that you want to get, go see another doctor. get a second opinion. I went for 7 second opinions, and it really saved my life.
Well, Fran Drescher from our Los Angeles bureau tonight, and apologies for the electronic breakup. They tell me it's because Cleveland and LA are in different worlds. Fran Drescher, thank you very much for being with us, and it is great to see you alive and well. The book is called Cancer Schmancer. We're going to take a break and take on a very touchy subject in our next segment. What about clinical trials? If the trial and thus the medication goes away from the patients who have learned to love them and need them. Stay with us. Once again, and welcome back. We are in Cleveland, Ohio, adjacent to the Cleveland Clinic. More on our continuing heart surgery that is going on this evening in just a moment. We are going to take on the very touchy subject of clinical trials in this segment. Specifically, what if the trial and the medication, especially one that has proven useful and life-saving for a patient, goes away. We are joined this evening by Elijah Lovejoy. Elijah Lovejoy is a lot of things. He is a former professor at the University of California, Santa Barbara, a member of the U.S. Foreign Service, a man with non-Hodgkin's lymphoma. Mr. Lovejoy, you pick up the story from there. You were on a medication in a trial, and what happened?
Non-Hodgkin's lymphoma, Brian, is a disease that goes on slowly, often for 10, 15, maybe 20 years. It is usually incurable. It usually ends in death, but you have a chance of managing it for a long period of time. Like many patients with this lymphoma, I had standard therapies, chemotherapy, which is effective and does affect your quality of life for a period of time. I had radiation therapy, which similarly was helpful, but made me sick for a while. I then had the chance to participate in one of the new targeted therapies, a radioimmunotherapy, in which an antibody is injected into my blood, which likes to be near tumor. This particular therapy was called Bexar. It has been under study for about a decade, and about 1,000 patients have had it around the world. The therapy is very, very pleasant from the patient's perspective because it does not make you feel sick the way chemotherapy or radiation therapy do. The essential process of the therapy is about a 1-hour infusion. So as a therapy, it is delightful. It also, in my case, was very effective the first time I had it. I had actually had a transformed non-Hodgkin's lymphoma, making it a more dangerous, more likely lethal tumor than the original one. And as far as we can tell, the clinical trial, this test drug, which had not been approved, called Bexar, knocked that new and powerful tumor either out or so far down that we could not see it.
And what stands between you and Bexar today?
What stands between me and Bexar today is that there were 2 such similar therapies under development. Many people in the cancer community thought that by about now, both would have been approved. As it happened, one, an alternative product, certainly a very good product called Zevalin, was approved a few months ago. And shortly thereafter, the therapy which had helped me, known as Bexar, was not approved by the Federal Food and Drug Administration. And at that point, the dynamics of the situation changed, and the company closed the protocol and said, we don't want to throw money into this drug at this point, given that it may not ever be approved for use with other subjects.
You stay right where you are. Dr. Slater, on behalf of the federal government. Here is a man who, modesty prevents him from saying this, was also representing U.S. industries at one of our embassies in the Caribbean during all this, a perfectly functioning adult who is trying to get healthy. Who does he see about Bexar?
Well, Brian, the real heroes are patients who enroll in clinical trials, and the government really does try and help both bring the therapies forward but also protect patients from false hopes and possibly therapies that do not work. I don't know the details in your case, sir. I certainly don't. I know for Gleevec, for example, it was approved in 71 or 73 days, Ron, something like that. And the FDA makes itself very available to work with the developers of breakthrough therapies to, in fact, enable them to actually design their trials in the proper way to get to the answer the quickest. So again, I can't speak to the specifics here, but basically, hopefully, we can avoid problems like this going forward.
Dr. Norton, all the king's horses and all the king's men in organized medicine. At Sloan Kettering, in your case, we have a man who needs Bexar. What do we do?
Well, one of the important things to know is that there's a mechanism called compassionate release, where we can often obtain drugs that are not approved, that have gone through the process of clinical trial development, and use them for individual cases. And I've done that in many cases. Obtain drugs that are not yet approved, or in some cases not going to be approved, but are helpful in individual cases. But this also indicates something extremely important that's generalizable for many of our problems. And that is that we have to start dealing with individuals rather than groups of people. Drugs get approved often because they work in groups of patients that go into clinical trials. Well, there may be individuals who are helped by certain drugs, but those individuals may be relatively rare. Yet for those people, those drugs are very important. And I think one of the things we're working on very hard is how to develop individualized therapy so that a drug that works for you is available for you, even if it's not available for large numbers of people.
And if that comes out of this evening, we call it a net gain. So many more topics to get to. We're going to check in live with Dr. Cosgrove, who is nearing the end of his surgery. There you see, we will talk to the good doctor after we come back from a break. Stay with us from the Cleveland Clinic tonight.
Summit for a Cure. From Cleveland, Ohio, here again is Brian Williams.
Good evening once again, and welcome back to our broadcast from the Cleveland Clinic tonight. Of all the subjects we have covered, one may be most complex of all, and that is the human brain. We've used a lot of numbers here tonight. The human heart beats 100,000 times in a day. Here's another number, 50,000. 50,000 Americans are diagnosed with Parkinson's each year. But speaking of clinical trials, the FDA has now approved something called deep brain stimulation. It is known in the trade as more or less a pacemaker for the heart. We caught up with one such case just last week right here at the Cleveland Clinic.
I was first diagnosed with Parkinson's in May of 1995. It just overtakes you. Everything revolves around my Parkinson's, it seems.
In this home video, Art Davis documents what had become a daily struggle with Parkinson's disease. He is 57 years old, but the effects of the disease had reduced him to a state of near infancy. Some days he was barely able to move, or there were the moments when his body was plagued by uncontrollable, erratic movements. He never knew which to expect. Medication no longer helped much. The only certainty in Art's life was that the symptoms of the disease were getting worse.
Which one are we going to?
Left door on the right.
It's 6 o'clock in the morning, and Art is facing hours of surgery. He is off medication and barely able to move.
I hope to be able to do things that I haven't been able to do. This disease has just consumed me over the last 8 months. The first few years, I was in control. But for the last year, it's been in control.
A couple of hours later, a team of surgeons are hoping to give Art some of that control back by working deep inside his brain. They begin by isolating the area in the brain responsible for the onset of Parkinson's. Art is awake for almost the entire procedure. The brain feels no pain. The surgeons have found the spot now where they need to be. They implant an electrode which will deliver a continuous electrical impulse to Art's brain and inexplicably ease his symptoms.
Let's go to 2 volts.
They experiment with a small amount of current in the operating room. Art is given some instructions to see if the stimulation has any impact.
Close and open. Close all the way and open. Fast as you can.
Look how, that's fantastic.
Very good.
Fantastic, good.
Tap your finger like this. Big and wide now. Big and wide.
Could you do that before, when you're off?
No.
The surgeons feel good about the way things are going so far, and so does Art. The nurses put his wife on the phone to hear the good news.
Having some good results. We're having real good results. I'll be able to chase you around the yard.
Okay, good. That's great.
The team's spirits are high, but the outcome is still uncertain. Once the surgery is complete, Art will spend the night in the ICU to make sure there are no complications. A few more rounds of surgery will complete the implant. And we are back. With me here tonight is Dr. Jamie Henderson, who we just saw at the other end of a piece of scientific equipment, and we are happy as well to say with us here tonight is Mr. Art Davis. Some complaints you're chasing your wife around the yard. When you look at that piece of videotape, that's you, and yet it must feel like an out-of-body experience.
Yes.
What does it feel like now, knowing that was still you then, but you had absolutely no control over your musculature?
I feel 20 years younger. I've not had one bad moment since I've had the surgery.
Doctor, people are listening to this. Everyone who just saw that piece of videotape is in awe of your skill and happy for Art. And they're thinking about Janet Reno, and they're thinking about Michael J. Fox. They're thinking about the public faces of Parkinson's and their uncle or mother or father with Parkinson's. What stands in the way between them and what you did for him?
Access is the only thing. The knowledge of the neurologists, the referring physicians, the general public, that this is an available therapy that's extremely effective. That's the only thing standing in the way.
If I were the Secretary of HHS, the President of the United States, and I asked you, tell me what I need to do to make this available to every patient who needs it, what would the answer be?
First off, there are government-level things that need to happen. Right now, Medicare covers this in many states, but in some states it does not. We're working right now for a national coverage policy so that Medicare will cover it for everyone, but it is widely available.
Art, I've seen this happen. Here you are, an able-minded man at the end of a good long career, and I am guessing that at the height of your illness, at least the physical manifestations, you were treated like a child, like something other than a full-grown man. Mm-hmm. Correct?
Correct.
A lot of patients complain about that. You're the same man today, but for a surgical procedure. Was there any doubt in your mind? Was there a hesitation before going through with it?
There was no hesitation. I was probably 3 months away from a nursing home. That's how bad I was. And I knew my family couldn't take care of me. Every night I'd have to go in the bedroom by 6 o'clock, or I wouldn't be able to walk. They'd have to carry me into bed, turn me over, pull the blankets up. I couldn't do anything. And I had no question about it. And I want to thank Dr. Henderson and Dr. Rasai and the Cleveland Clinic. They did an outstanding job. And I want to thank all the people who prayed for me. I had hundreds of people in 5 different states praying while the surgery was going on. And there's power in prayer. And it works, believe me. I'm so excited. I could turn somersaults up here on the stage.
Well, good for you. We're absolutely. One of the topics we're going to get to, insurance, is precisely why I'm not going to allow you to turn somersaults on the stage. I'm going to limit your activity to chasing your wife around the yard. We're talking about all these breakthroughs, and while we're talking, people are sitting at home. They were sons and daughters, and suddenly they are caregivers. They were peers, and suddenly they are caregivers. Dr. Small is here to take us into the world of Alzheimer's. We have watched too many adults, Doctor, decay. What can you tell us? What is the equivalent of the hope that this has given us here this evening?
Brian, this is a devastating illness, but there is tremendous hope. It is an exciting time with Alzheimer's research. We've found using new technology like positron emission tomography, PET scanning, we can diagnose Alzheimer's years before we were able to before. We're even seeing early brain changes in people very young, 30s and 20s. So it's never too early to get started on preventing brain aging, keeping our brains healthy, which motivated me to write a book, The Memory Bible, to tell people what they can do now to keep their brains healthy and young and stave off future memory loss.
For the cynics who say it's going to get me or it's not, that preventative therapy on something as overarching, as devastating as Alzheimer's is not for me, what's your comeback?
Genetics is only 1/3. 2/3 is environment and lifestyle choices. And a lot of the lifestyle choices we've heard about, things that are good for the heart, good for the brain as well. So a healthy diet, low-fat diet, lots of physical exercise, actually mental aerobics, keeping your brain active is very important. Studies have found that people with a college education have a lower risk for getting Alzheimer's disease. So there's a tremendous amount of things that people can do now.
You raise also the early markers, early in life. And Dr. McGee, I want to ask you, more and more tonight, we're hearing that there are calling cards, much earlier than we first thought. I'm 20 years old, I'm young and vigorous, and a test tells me that I'm going to enter a very dark and seemingly hopeless hole when I turn 50. Do I want to know that? Do I want my insurance company finding that out?
Well, you don't want your insurance company to know, but there's no question you'll be able to know. Within a decade, you'll be able to put your thumb on a tiny pad and run 20, 30, even 100 genetic tests and find out everything from whether or not you're likely to have Alzheimer's or Parkinson's to what kind of heart attack you might have or whether you might lose control of an automobile. These are the kinds of things that might be helpful for an employer to know or an insurance company to know, but they turn the attention away from the good things we can do to take care of our health to the blame that institutions can put on people for not doing them. So if you had that gene and you didn't go with a good diet, maybe we won't cover you. Maybe we won't give you the life insurance or the health insurance.
God and patients everywhere forgive me for asking, but when you and your peers at Penn and elsewhere get together and you take on the hypothetical, what if we cured everything? What's the answer? Where do you come down? Is there any way that's not a good thing?
Sounds great. I think it's clear that for every discovery that we've identified in the last 10 years, we've opened up a whole range of new kinds of problems. Just take the genetic analysis of heart disease. There are now hundreds of brewing tests for things that you might inherit that can contribute to one day having heart disease. We might find ways to stop what we've long thought of as a heart attack or long thought of as a valve failure. But will we in the long term be able to change the little bits and pieces of our genes that mean that if I live in Colorado where the air is thin, then I'm more likely to have heart disease. If I drink the wrong water, I'm more likely to have heart disease. If I get married and it's too stressful, I'm more likely to have heart disease. I don't know, but weighing those really unbelievable kinds of dice throws is the future. And how to think about that is going to require us to have real time with real doctors who talk to us. And when Fran Drescher said, you know, I saw 8 people, part of the message she's sending is I was sad. They weren't giving me the right answer. I didn't know. But what I take away from that is we are also living in an era when doctors are strangers to us and people get their information on the internet. This new genetic information requires us to have people to talk to, too.
On the topic of genetic information, we're going to take on a hot one. It started out as science, became medicine, and then we all watched it become politics. The debate over stem cells. We will be joined live here this evening by actor Christopher Reeve, right after this. Good evening once again from Cleveland, Ohio. Thank you and welcome back. It was in so many ways the ultimate irony, and forgive me for restating the obvious. For so many, Christopher Reeve was, after all, Superman. Say nothing of how much he was loved at home and still is by his family members. Say nothing of the character he played on the big screen. He was and still is beloved by millions of American moviegoers who have watched him face another struggle since we all heard the news he had been thrown by a horse in 1995. Even as a veteran equestrian, he has been in a wheelchair ever since. We know him most recently from his vehement political defense of stem cell research. He is with us this evening from his home outside New York. And Mr. Reeve, as simply as you can, state the argument for stem cell research.
Stem cells can become any tissue in the body, and when you add somatic cell nucleus transplantation, which means that you're able to use the patient's own DNA, you'll be able to safely provide cures for millions of diseases. For people suffering from those diseases.
Buchanan is with us as well this evening. She's a former treasurer of the United States, former treasurer of the 2 Reagan campaigns, if I'm correct. She ran a couple of campaigns for president for her own brother. She is decidedly on the other side of this issue. Bay, what do you say to Christopher Reeve and others? Why not?
Well, there's 2 points, Brian. First is that in a good and great country, you do not permit the harvesting of human life for the sole purpose of destroying it for medical purposes. That's just an unacceptable policy. You know, the means, however good the ends is, it cannot justify the means. The means must stand up on its own, and in this case, it's destruction of human life. But the good news is, from what Christopher has just pointed out, is that we have a real breakthrough in adult stem cell research. We just learned this week at the University of Minnesota that they have managed to determine that there is a cell within the bone marrow, a stem cell there, that can differentiate into all the critical cell types in a body, and that this is something that is much more likely to be acceptable by the body because it will less likely reject than the embryonic. So the real great hope here, Brian, I believe, is in adult stem cell research, and that is absolutely ethical.
Chris, hold for me one second. Hold for me 1 second. We're going to go back to you. You're as tough as they come on this subject. Dr. McGee, I'd like to bring this inside this room. You make a very interesting point on this subject. How did this become the debate? When did it become, to use the quote, harvesting of human life? When did it become politics? When did it become about abortion?
It's funny because it really shouldn't be a debate about abortion. It was framed that way when the discovery initially got passed to those folks who'd been fighting about abortion for 30 years. In the United States, there's a new debate, and just this past week in the newspapers, you read congressmen and senators talking about what counts as an embryo, what I like to call what's in the dish. We don't know what some of these things are. It may be early to say that they are or aren't human life, but whatever you think about them, I think both sides can come to agreement that it'd be better not to use stem cell research that would destroy an embryo to make hair cream, on the one hand, and on the other hand, that we ought to be careful before we say that embryos that have been frozen for 15 years or that have been created through a technology that might not even be able to make a baby are a human sacrifice. We got to figure out how to answer those questions. And in the U.S., we've got a real bankruptcy when it comes to a way to talk. We don't have church leaders trained. Congress doesn't have a research agency dedicated to this. So what's the next step? We've just kind of floundered, and we've seen finally it degenerate into a political morass.
Christopher and Bay, please hold. Dr. Slater, is that a liberal view? Your boss was really over a barrel on this issue.
Oh, I don't think so, Brian. What the president did was he enabled stem cell research to proceed, and there are some very systematic questions that need to be answered. What the president simply did was he respected the very polarized views of Ms. Buchanan and Mr. Reeve. And hello, Christopher, we saw each other about a month ago. And what he tried to do is he said, these are federal dollars now that I'm responsible for, and the research that I'm responsible for has coming with it these varied views that really are very morally important to people. And so he simply put some boundaries on that research for the federal dollars, whereas, you know, private companies can do what they want.
Christopher Reeve, you are to be commended for your patience. Please go ahead.
Well, first of all, I didn't say anything about adult stem cells in my commentary, and also the University of Minnesota has made it more than clear that they are pursuing embryonic stem cell research just as vigorously as adult stem cells. Also, there is no clear indication of what adult stem cells can do because they combine with other cells in the therapy that they're being used for. So they have not been isolated the way that embryonic stem cells have. And one other point that is very important to make is that somatic cell nucleus transplantation takes an unfertilized egg. It is not the union of male and female, and it's only a few days old. It has no human characteristics, and what you can do is take the nucleus out of that egg at about 3 days and put the patient's DNA into it and get stem cells that way, and never will those cells ever leave a laboratory.
And baby,
or be implanted in a womb, and that with the patient's DNA, then you have a reasonable measure of safety to provide therapy.
Babe Buchanan,
that's why they must be pursued.
This man who is able to join us this evening only thanks to a number of machines. Your view on the issue of life is such that your answer to his argument, no matter how well-developed or multi-layered, is a firm no.
No, you can't justify it. No matter how honorable and good, Brian, the end is, the means has to stand up for itself, as I said before. And it has to be a righteous means. You cannot have some process of destroying human life and say, well, it is okay in this circumstances. It's not for hair cream, it's for saving other lives. It is never acceptable to take human life. And that is where we stand now. You're creating a subclass of humanity here that doctors should be able to do with what they want. It does not have the same rights as the rest of humanity. That is a real dangerous direction to take for this country, and that's why Congress should step in.
Okay, Christopher,
it is human life.
And
it
we
is
hear,
human life.
all right,
Sure.
Dr. McGee.
It's not a human life.
Hold on 1 second. Dr. McGee, again, part of your point is we don't know what we're arguing about. This is the stem cell debate in the United States. There are no more articulate spokespeople for either side of this cause, and like it or not, it's heavily political, it's moral, it has to do with life and death, and it has to do with serious injury.
Absolutely, and it's tough football. Listening to this is really hard because so many lives are at stake. We don't know yet how effective stem cells will be. Gene therapy looked incredibly promising 10 and 15 years ago. Indeed, it may pan out. Will stem cells be the panacea that saves millions of lives? I don't know. I don't think any of the stem cell researchers will promise you at this point that it's going to open up the cures to everything in the world. But the bottom line is that we have to be clear about what the U.S. has done. The president has essentially shut down federal funding for stem cell research. His paltry allowance of $300 million won't begin to cover a real research program in the U.S. Leaving it to private industry was his initial position, but then he changed his mind in the Rose Garden about a month ago, and as we saw, the political debate about therapeutic cloning and so on left us all confused about where the president really stands. This is going to be a big issue in the next election. It's a big issue right now for people with all kinds of diseases. How do we get our government to help us on this question?
Dr. Willard, there are people watching saying, perhaps, I am anti-abortion, vehemently. I am very much pro-Christopher Reeve. Perhaps I have a grandchild who is also in a wheelchair or facing serious illness that could be solved because of this. People don't know even where to stand, where to come down, what to think. It's not an easy one.
Hey, you're absolutely right. But the answer is more research. The debate, at least from a scientific perspective, is to compare what adult stem cells can do, to follow up on the very promising results from the University of Minnesota and other places, and compare that to the results that one might get on the few embryonic stem cell lines that research is permitted on. This government is allowing a certain level of research to go on in this country. Other countries are carrying out that very same kind of research, and the private sector is carrying out some of that research. So time will tell and allow us as scientists to actually weigh the data and say, well, for this disease, this seems to be the right answer. For that disease, the opposite.
Babe Buchanan and Christopher Reeve, beginning with you, Bay, I can really, literally only give you about 30 seconds each because we're going to lose the satellites. Go ahead.
All right, the president has to make a decision, and so does Congress. There's limited research money. Let us put it where all Americans, it's their money, where all Americans can agree that we have real hope, and that's adult stem cell research. That is something we can all support, and hopefully the answers will come there and help the Christopher Reeves of this country.
And Christopher Reeve, a final thought for all of us.
Well, the fact is that we have to pursue this research to see where it'll go. Then it is not fair to say that just a few cells that have not been created by the union of male and female have the same status as a fertilized embryo done the conventional way. It's totally different.
Christopher Reeve, Bay Buchanan, again, of course, our experts in this room. Thank you. We are going to take a break, and when we come back, we are going to talk about what many experts will tell you is a topic that needs a good and thorough airing. Put simply, every life must end. It's a part of medicine. Death, very much a part of life, is enough being done for that end of the human existence. We will continue from the Cleveland Clinic right after this break.
Summit for a Cure continues from Cleveland. Here again is Brian Williams.
Good evening once again, and welcome back to our broadcast. And now be honest, how many people during the course of this discussion, during all of this talk of perhaps daily testing for the next ailment or the next genetic marker that may be coming along in the life of a 5-year-old, have muttered to themselves or a loved one next to them, life's too short? Well, that's exactly the problem, and it's the subject of part of our next segment. Dr. Ira Byock is with us all the way from Montana. His specialty is care for the dying, the end of life, the end of all the cycles we discuss here tonight. Palliative care is the name for your specialty, and Doctor, I want to hear you out on exactly that.
Well, I think the challenge here is to not let our exhilaration that I feel as well as a physician and eventually a patient, a loved one, for these cures dissuade us or deny the fact that all of us will eventually die. That's what the studies continue to show.
That's true.
And so, you know, we're going to double the NIH budget, which I, for one, think is a good thing, but there's yet to be sufficient attention on how we die. And in fact, the Institute of Medicine and other studies have shown that the way Americans currently are cared for and die rises to the level of a true crisis. At some of these same leading medical institutions, people are still dying in pain. If you interview patients or their families after a loved one has died, they'll tell you that they often feel that they had fallen through the cracks, that once cure was not possible, they felt somewhat neglected and abandoned. Communication was poor. Continuity of care was just a dream. So I think the challenge for us really is to learn what we can about comfort and quality of life, and then use that widely. It wouldn't take that much money to do. And in fact, some of the more recent studies and programs right here in Cleveland, in fact, the Ireland Cancer Center and the Hospice of the Western Reserve are finding that if you do both at once, if you provide oncology care and hospice care together, it's much more effective than either separately.
Let me ask you this. Some of this is not very gently talked about in American society, and I don't mean to tell you what you already know. I have a $7 million titanium prototype heart backstage here tonight. At least it just was before the commercial break. What if that goes into the chest of an 80-year-old with congestive heart failure? Every other member of our audience tonight and watching at home has a loved one at the end of life with congestive heart failure. These become the tough decisions of literally life and death and allocation of resources. And who do we see about that?
You know, it's really tough, but we have to start with a firm commitment that people's quality of life matters. None of us gets out of this one alive. And so how we live day by day is really what impacts most Americans. In fact, I mean, we will die of chronic illnesses. You cure heart disease, we will simply die of something else. And I think the real advances that would impact most people's lives today are in the realm of health services research, health service delivery. That's what we really need to study. And I would challenge the NIH and the government and pharmaceutical companies to put really money into putting life into the time that we have left. We all know that dying is a fact, that, you know, that death awaits us, but how we die really matters to not only the patients who are going through it, eventually all of us, but to our families who will live on with the memory of our last days.
Dr. Byock, thank you for being with us here tonight. It is, in a 2-hour conversation, less time for commercial breaks, of course, a very tough duty to cover all of medicine. And as you've seen, the good news and bad here tonight. Our next topic is a tough one, and one that has left the spotlight in a way. We are joined tonight by Robert Toth. He is an AIDS activist, a native here in Ohio, someone who has been living with HIV/AIDS, I understand, for 15 years. And Mr. Toth, when last Americans checked in, those without a friend or family member with the disease, the cocktail was working. There was hope. Why, we saw magazine cover stories to that very effect. Is part of the problem, quote, when last Americans checked in with HIV and AIDS?
Exactly, Brian. With a national HIV infection rate of 40,000 new infections a year, of which at the very least 20% are resistant to one class of HIV drug, multiple drug resistance has become a reality, even with the other drugs that have been available. And we have become complacent with that. We are showing that multiple drug resistance to these new drugs is a reality for new and existing people living with HIV/AIDS like myself. And my question could be directed to Dr. Slater is, when can we expect the same level of compassion and zeal now being shown in the global AIDS effort to exert itself in combating this emerging public health crisis issue
Dr. Slater?
Here at home?
Well, thanks for your question, and believe me, we really hear you. The President is very concerned. We're talking about roughly $13 billion now of U.S. money that's going into a combination of both health research, HIV research, as well as services within this country for research. The President has just committed $500 million to a special effort. This is not part of the global fund, but a special effort to treat women in the Caribbean and in Africa, and to try and prevent maternal to child transmission. You know the numbers better than all of us, but basically the projections for the numbers of orphans in these areas are just stunning and disturbing to all of us. So this is a start, and the plan is really to bring the money along with the development of the infrastructure, because as you know, it's simple to just say, okay, we're putting this money and we're walking away. The responsibility really has to be the dedicated people on the ground in these areas to help really begin to rebuild the kind of care, both outside the U.S. as well as inside the U.S. So it's a combination of money, care, medicines.
Dr. Slater, Mr. Toth, and our audience, thank you both. It is a topic, it is a disease that is consuming a generation of Africans, and soon, according to American politicians and the United Nations, if we look away or look it straight in the eye, it is about to, in every inch and in every way, become the American problem as well. We will take a break here. When we come back, a few topics. How do we cover everything we have talked about tonight? Who gets to use all the advances? Who profits? Who gains? And who loses? Right after this. Good evening once again, and welcome back. We're back in Cleveland, just adjacent to the Cleveland Clinic. We haven't forgotten about the heart surgery in progress, or Dr. Cosgrove. We're going to check in with him and his patient a bit later on. Still, that bugaboo remains with us, though. Taking echinacea for a cold. Dr. Oz, I'm not sure we answered it before. People are listening tonight, as I mentioned, using that expression, life's too short. You know these people. They're the ones who believe a padded dashboard is preventative care in the automobile. What is the happy medium? Is yoga going to prolong human life? Will aromatherapy prolong human life? What's the mix between all this Western science we're hearing about and the more Eastern views that you've written about?
Well, I think, for one, we should emphasize that if death is the enemy, then you're looking at 8 losers, because really the focus should be on quality issues. Now, we have global communication systems, we have global banking systems, people all over the world are watching this broadcast. But medicine is not global. medicine is a remarkably provincial activity. It is tempered by the cultures from which we as physicians arise and by the patients who visit us. So when we start evaluating echinacea or yoga and alternative therapies like prayer, as was mentioned earlier on this program, it challenges our scientific underpinnings. And I think that brings us really to a recognition that we have a responsibility as leaders in medicine to look in other areas of the world, even within other parts of our country, for anything that might help. You know, Brian, if juju beans help cure the common cold, we should try it, but we should study it. I don't mean to advocate for alternative therapies, but I do believe we should, in an organized fashion, evaluate them.
Dr. Norton, Sloan Kettering, people come to you at almost a hospital of last resort. Often, as you know, they've been recommended to you and come to you from all over the nation and the world. Stage 4 lung cancer, looking you directly in the eye. What do you tell them?
Well, we see a lot of early stage disease as well. It's not just the last resort. And I think the attitude that cancer is a death sentence is a very bad attitude. In fact, that even now we're doing a lot to help people. Lance Armstrong is a very good example of somebody cured of a very advanced cancer. And we're open to a lot of approaches. We have a very active, vibrant integrative medicine service that's looking at many of the same things that we're talking about. In fact, I challenge the word alternative medicine. I think there's medicine and there's non-medicine. Anything can be studied with the scientific process, and I think it's appropriate to study all of these things in the scientific process to find out what works. All of us want to do what works to help all of our patients.
How should people live that they're not living right now?
Well, I think one of the common themes that we're talking about here is prevention. That's something that we have to talk about a whole lot more. Cancer can often be prevented. We didn't mention cigarette smoking, for example. That's probably the single best thing you could do for yourself is not to smoke. And if you're smoking, to stop at any age. Even after diagnosis of lung cancer, it's good to stop smoking. So there are many lifestyle things that we could do, but also we should support research, we should support clinical trials, we should open up our minds to all sorts of things that can be tested with a scientific method. And if we have that very positive attitude, that's really where we're going to make progress.
Dr. Willard, I know you spend a good deal of your time thinking about the American condition and the condition of health care in the United States. You are up against a certain mindset, a certain attitude that, quote, it's going to happen to me either way. I could die tomorrow if I was hit by a bus. And here we are talking about perhaps finding these markers in very, very young people. Are you seeing a change in attitude slowly as America gets a little older and wiser?
Well, the biggest attitude change is people coming to grips with what genetics is and what the human genome is, which has been the single greatest piece of human education that's gone on in the last 5 to 10 years.
How do you explain the genome to a layperson?
The genome is the collection of all of the genes contained within each of our cells that instruct the body how to run and sometimes how not to run. That's the simplest way of looking at it, and you can get as more complicated as you would like. But the geneticist really is an advanced form of being a bookie. We're good at telling the odds. We're getting better at telling the odds the more information we get about the different kinds of genes that are in each of us and the different flavors of the genome, if you will, that there are around the world. But we're still just a bookie. We can't promise you that you'll get a disease, nor can we promise you that you won't get a disease. So we're simply trying to tip the odds, and I think that's where the other aspects of the human condition come into play. If they can help tilt the odds in the favor of the patient or in favor of a family, then by all means we should study it and take advantage of it, because when it works, it'll work well on behalf of an individual and his or her family.
What's your answer to the rejoinder, I don't want to know?
This is individual choice at its best. If someone doesn't want to know, they shouldn't have to know. The genetic material is there to be studied, and for individuals who want to know that information to take advantage of it and become perhaps masters of their own health care, or at least to integrate that knowledge into their own health care. But there are individuals who quite rightly will say, as you just said, I don't want to know this information, and I shouldn't have to know this information, and I think that should be allowed as well.
We're going to take a break, and when we come back, we are going to try to answer all of the comments and questions voiced since we've been on the air, like, well, when did we come to a day when insurance companies have to be kept away from certain information? Who pays? Who is allowed to get the technology discussed here this evening? And how did that heart patient do tonight next door? We're back in a moment from Cleveland right after this. Welcome back once again here at the Cleveland Clinic, as I mentioned, roundly believed, certainly by the physicians who work here, as #1 in heart care and heart surgery around the country. We mentioned operations are going on around the clock. We were fortunate enough to watch one in progress tonight and think of what we saw. We watched the unthinkable just years ago, thanks largely to Dr. Cosgrove, the inventor of so many of the tools and procedures tonight. Dr. Cosgrove, actually in private life, very handsome man when you take off the mask and the goggles. He is with us tonight. Surgery is ended. Doctor, how are you? How's the patient?
Well, we're both fine. The patient has done very well. He's awake and talking to us. The valve is working beautifully and there's no leak at all. He's on his way to the intensive care unit shortly and should be there just overnight.
Did he think he was undergoing any risk? I think you mentioned 0.5%. The doctor-patient briefing on the eve of what we have to still call open heart surgery used to be a very momentous, sometimes emotional affair.
Yes, it always is a very emotional affair. And one of the reasons I'm glad you brought that up is because I want to thank you, and the patient also would like to thank you, because both of us as educators realize that you gave us an opportunity to talk to a very large audience and hopefully to alleviate the fear that's associated with medical interventions. We know that if we intervene earlier, we have many more options and the results are better, and ultimately the patient does a lot better. So we hope that tonight we'll begin to alleviate that fear and take some of the mystery away from cardiac surgery. You know, it's a privilege to look after patients, and it's a particular pleasure to look after someone and have a result that is going to return them to a normal life. We think we've accomplished this today with Professor Gold, and we think he's going to have a perfectly normal life from here forward.
Well, that valve was on us, by the way. We at NBC News feeling in a generous and expansive mood tonight. Doctor, you mentioned the success rate of the surgery and how this once momentous, once very scary and monolithic procedure is now reduced to something so seemingly simple. And we mentioned earlier your ability to look at household objects, really, and transform them into medicine. Use that as a starting point. Analogy or metaphor. Should we be doing more of that in science and medicine?
Well, I think what we've done is had a tremendous explosion in new knowledge. You have to understand that there's been more new knowledge created in the last 40 years than in the previous 5,000. And medicine is simply exploding. And that gives us an opportunity to bring better care to vastly more people. You've seen tonight fabulous things that wouldn't even been dreamed of 5, 10, 15 years ago. Cardiac surgery, for example, has gone from an operative mortality rate routinely, which was 25 or 30%, to something that's under 1% now. And it's now safe to do these procedures on a large number of people and do it safely and efficiently. This is a great step forward for humans, and it allows them to return to their life and contribute to society. It's a fabulous era that we live in, and I am fully convinced that we are going to use our new knowledge successfully to bring better health care to all sorts of people all over the world.
Well, somewhere in a classroom in California in about 2 weeks, a math professor is going to be back up before the blackboard or whiteboard, because times have changed after all. Doctor, it's great to watch a great man do something we all envy and admire, especially something that prolongs and enriches life. Dr. Cosgrove, thank you for being with us tonight.
Thank you for having us. Our pleasure.
Where to begin? Dr. Topol, you're an associate, of course, and for those watching this evening without the best insurance company, without the highest income, they need a valve job, like our very, very fortunate professor from California. What do we tell them?
Well, this is a very big problem. You've heard the theme tonight about how all the advanced technologies, whether it's a new medical therapy like Reeve, deep brain stimulation, mitral valve repair, artificial heart. So how are we going to go ahead with rational rationing in the future? Some of this could be done through personalized medicine, through knowing the genes and proteins. But of course, some of it is just coping with an immense burden of being able to now remedy many diseases and not really having the resources. We in the U.S. are now confronting what the rest of the world has been confronting for many years, which is having to go into a rationing mode, and this is really tough.
Dr. Small, I asked you at the beginning of the evening, is the glass half full or half empty? How optimistic are you?
I'm optimistic because we have the know-how, we have the technology. What frustrates me, though, is this whole issue of access. We talk about all these technologies and people not getting them, not having them available. PET scans for the brain. We know that it can diagnose Alzheimer's disease earlier. It can be very effective, but we don't have Medicare coverage for it. It's very frustrating. I know millions of people would be helped if they had that technology.
And Dr. Kroll, you have the technology. And sometimes some of the people here tonight, it's a grandiose way of saying it, have to play God. What do you do about that mantle?
Well, one of the things we try to do when we're developing drugs is to think about people who could benefit from our drugs even before they're available. For example, we have a new medicine, as I said earlier, for lung cancer. We've been able, through an expanded access program, to make that drug available to more than 10,000 patients, even before it's approved. Those are the kinds of things that we can do in the private sector to respond to the need of patients for medicines.
Dr. Norton, again, because we have to answer to so many cynics and because the emails begin while we're on the air, when you say, as you did earlier tonight, it's a matter of time, that gives so many people so much hope. They want to believe so truly and so badly, but a lot of the people don't sense it. It's not coming for them.
Well, they have to know that it's happening, and we will have to make it happen faster. That's really our job. So many of the topics that you're bringing forward, issues of access, issues of politics, issues of funding, these are really critical issues because the ideas are there, the technology is there. Now it's a matter of doing the hard work and making a major national commitment to accomplishing the eradication of cancer, which is not only possible, it's going to happen. We just have to make it happen faster.
Let's let that be the last word, from which, after all, is a very hopeful place, the Cleveland Clinic in Cleveland, Ohio tonight. Yes, it's a matter of time for some of the patients who are suffering from the various diseases we have talked about here tonight, but also, as we have just heard, from the finest minds in their field in medicine, science, and technology in this country, it is a matter of time. The great nation, the United States, is also on the cusp of true medical breakthroughs. The kind of revolution some say, some swear, is already underway. The challenge just might be making sure that all Americans get to benefit. With our thanks to the great city of Cleveland, Ohio, our friends at the Cleveland Clinic for all their hospitality and generosity, I'm Brian Williams. Thank you very much for being with us.